So now let's value a bond with semi-annual coupons, and let's assume a coupon rate that's equal to 12%. Par value of $1,000. Our term to maturity, let's say, is 7 years. And our discount rate, our annual discount rate is 10%. So our bonds are, our coupons are paid semi-annually. So our annual coupon will be 12% of the $1,000. That's $120. So our actual coupon payment, which is our semi-annual coupon, will be $60, half of that. Our par value remains at $1,000. Whether the bond pays coupons annually or semi-annually, we're still promised to receive that $1,000 when the bond matures. Our term to maturity is still 7 years, but notice we're receiving $60 every 6 months for 7 years. So how many periods are we going to be discounting that annuity stream of coupons? 14, twice that. So our N here is going to be 14, which is equal to 2 times that 7 years. Now our rate here, that's 10% per year. For simplicity, let's just assume that that rate is a nominal rate. It's not an effective rate, so that we can just cut that 10% in half and get 5%. Now realize, if we're to get our rate for every 6 months, to get a 6-month rate, let's just cut our annual rate in half to get 5%. Now, if you're actually making 5% every 6 months, that's going to result in an effective annual rate that's greater than 10%. You see. But for simplicity's sake, let's just say that our rate here is 5% per 6 months, by assuming that this 10% here is a nominal rate. The 10% is a result of the 5% multiplied by 2. So the price of the bond is equal to the present value of the coupons, which form an annuity, so we can use our present value of an annuity formula, plus the present value of that single lump sum amount of $1,000. So we're going to be using our present value of an annuity formula and just a simple present value formula. So plugging everything into our present value of an annuity formula, we can put $60 here as our payment. Our rate is 5%. And you may notice I always put parentheses around this 1.05. I don't need to. I'm just used to it because whenever I'm writing out this formula in general terms, it's 1 plus r, and you put that in parentheses to designate that the n is an exponent to the 1 plus r, not just the r. And so out of habit, I just put these parentheses around the 1.05, but it's really not needed. And so that is going to be raised by our N of 14. That's the present value of the coupon annuity. And then we're going to be taking the present value of the $1,000 par. Let me skip the parentheses on this one. Again, that's being discounted at 5% for 14 periods, 14 6-month periods. And so let me input those into the calculator here. And that will give you time to calculate. What price do you have? I have 1,098, so either we're both correct or we're both wrong. And 99 cents, rounded to the nearest cent. So that would be the value now, or the price of the bond that pays coupons semi-annually given this information here.